So now one more thing about a minus b is it is a minus not the entire b, this much just common portion, so which represent this a minus b. So we can write a minus b is equal to a minus a intersection b, not here minus b. And same way this b minus a portion, which is from circle of b, you drop the common portion. Common means a intersection b. So second one is b minus a is equal to b minus a intersection b. So this is also one more important result about a minus b and b minus a. So you recall the complement. If this is universal set here, this is a set A here, then this exterior portion, that is the members of universal set which are not in A, that is known as A dash. So this is A dash, which is indirectly, you recall, A dash is nothing but the universal set minus the set A. This much we know. Now here we might have noted earlier, if you combine the set and its complement, combine means if you take their union, set and its complement, you will get the entire rectangle, which is universal set. You also know that there is no common in the circle of A in this shaded region. So A intersection A dash is phi, that you know. Second thing here, if I write here complement of phi, that is phi dash. So here phi dash, that is u minus phi, so it is just universal set. And reverse, if I write u dash, that is u minus u, which is phi. This is always true. And one more thing, you find a dash, so you'll get this shaded region. Again you get the complement of a dash. So in the rectangle, the other than this shaded region, so what you will get again the circle, so that is A. So if you take complement twice of any set, you will get the set itself. Now next property, that is about complement again, which is called De Morgan's laws or properties. De Morgan's. Now what it says, the first property says that you find A union B and then whole complement, that is always equals to A dash intersection B dash. So what happens here, when you take complement inside, this union becomes intersection, and second one is just the reverse of this. A intersection B the whole dash is equal to A dash union B dash. So again intersection become union, so operation get reversed. These two properties are very important property in sets which are called De Morgan's. A union B the whole dash is A dash intersection B dash. A intersection B dash is A dash union B dash. Intersection union union intersection. Not only for two sets, this holds for any number of sets. For example, I have this here, A intersection B intersection C the whole dash. So you can write A dash union B dash union C dash for three sets. Even if I have like this, for example, A union B intersection C, here let me write dash, the whole dash. And if I take this dash inside, so this is A dash intersection become, sorry, union become intersection B dash, this bracket as it is, this become union, and here you have C double dash, which is C. I've used this indirectly. Complement of C twice is a set itself. So this is always true. So here next point is about number of elements in a finite set. So let's take, let A, B be two finite sets, be two finite sets. You know what's the meaning of finite sets? That means they have some fixed number of elements like 5, 10, 100, 20 and so on. Then we use the symbol here. small n, inside the bracket we write a. This is read as n of a. It means number of elements in a. If I write for example n of b, that means number of elements in b. So n of a is the standard symbol for number of elements in a, and n of b is standard symbol for number of elements of b. This is not n into b, n of b, n of a. For example here, if I write, let's take a equals to, let's take 1, 2, 3 members. B equals to, I have for example, let me write 3, 4, 6, 8, 4 members. So then you can find A union B. So what is A union B here? Combine the sets 1, 2, 3, 4, 6, 8. What is A intersection B? That is common element. So there is only one element common, which is 3. So this is just singleton 3. What is A minus B? All members of A which are not in B. 3 is there, so it is just 1, 2. You drop the common. What is B minus A? That you can write all members of B which are not in A. So 4, 6, 8. 4, 6, 8. So here you can write n of A equals to 3 members. N of B equals to 4 members. N of A union B, so 6 members. N of A intersection B, just 1 member. N of A minus B, 2 members. N of B minus A, 3 members. Okay, so here if you see this, N of A union B, that is 6, which is n of A plus n of B. So 3 plus 4, 7, minus common, that is n of A intersection B. This is always true, remember. So you can find union without finding explicitly the union. From members of A and B you can do this. So this way you write as the first result here. First result, that is n of A union B equals to n of A plus n of B minus n of A intersection B. This is always true. You might have studied in 10th standard in probability. There it was about P of, but here n of A union B equals to NA plus NB minus n of A intersection B. If A and B are disjoint sets, you know what you mean by disjoint sets. If A and B are disjoint sets, disjoint means they have no common elements. So then A intersection B is 5. So number of elements in A intersection B is 0 because there is no common element. So in that case, above formula reduced to n of A union B equals to n of A plus n of B. Now for 3 sets, n of A union B union C, that is number of elements in the union of 3 sets, which is equals to this. Without proof we are writing n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A. So here single set, here double sets, and plus alternative sign. In first 3 plus sign, then minus sign, and then at the end plus. A intersection B intersection C. This is sometimes called addition rule here. For 3 sets. The first one was also addition rule. So it's like this. This is a set A, for example. This is a set B here. And this is a set C here. And this is universal set here. This is universal set. So number of elements in the union of these three sets, that is given by n of A plus n of B plus n of C minus A intersection B, that is this portion, minus B intersection C, which is this portion, minus A intersection C, which is this portion, plus common of all these three, that is this one. This is a common in all the three sets, remember this portion. Okay. Now next, third one here, that is number of elements in A minus B. This is A, this is B. You know A minus B is this. So what is that? Number of elements in A minus this much only. So this is equals to n of A minus n of A intersection B. And number of elements in B minus A, that is this portion. I'm talking about this portion, which is n of B minus common n of A intersection B. Here remember n of A minus B, that is equals to n of A minus n of B. This is wrong. Not minus n of B, minus A intersection B. So these are again very important results. Fourth one, you know this is sometimes read as only A, this is read as only B. Next, number of elements in A dash. So which is again so simple. If this is the rectangle here, which is universal set, this is a set A. So you want members in this. So that is number of elements in the universal set, entire rectangle, minus number of elements in A. This is always true. One more thing, we use this sometimes. If you have, for example, n of A dash union B dash, so you can use De Morgan's here. A intersection B the whole dash. What is this? This is De Morgan's. You take dash outside, so union becomes intersection. Now you imagine this is a set A, this portion only. So like A here. So what is that? Number of elements in the universal set minus A. A means here A intersection B. So we can use this way when you have double dash. So we go to next exercise 1.6. The first question is, for two finite sets, number of element X is 17, number of elements in Y 23, union has 38 members. You are asked to find the number of elements in X intersection Y. So let's see this. So here n of X 17, n of Y 23, n of X union Y is 38, and you are asked to find number of elements in X intersection Y. Okay, so we use this addition rule. This is sometimes called addition rule. What is that? Number of elements in X union Y equals to n of X plus n of Y minus n of X intersection Y. So you have this one, which is 38, n of X 17, n of Y 23, minus, this is what you want. So if I just interchange this, n of X intersection Y, this is 40 minus 38, so you'll get the 2. Same way you can find these also. This is not asked in the question. Number of elements in X minus Y, which is number of elements in X minus number of elements in X intersection Y. So which is 17 minus 2. So it will be 15. In a Venn diagram, this entire entire X has 17 members. But in this you have 2. So obviously in this portion you will get the 17 minus 2, which is 15. Same way, number of elements in y minus x if you want. This is y, so you want this one. Now this entire circle of y has how many members? 23. Minus common, which is 2. So you will get here 21. Now by formula, if you see, this is n of y minus n of x intersection y. Second question is, I think, same question. Union has 18 members, x has 8 members, y has 15 members. You are asked to find number of elements in x intersection y. So you can do that. We go to third question, where in a group of 400 people, 250 speaks Hindi, 200 speaks English. You are asked to find number of people speaking both. Here both means this, and you know and stands for intersection. So you are asked to find the number of elements in the intersection indirectly. So let's see this question. So I'll take two sets. Let H be number of people speaking Hindi and E be the number of people speaking English. Let me take this way, H and E. So therefore, number of people who speak Hindi, that is 250 given to you. Number of people who speak English, which is 200. Number of people, total persons, that is union, which is you are given 400. And you are asked number of people who speaks both, that is E intersection H. So this is a question. Okay. This is what you want to find. Remember, both stands for intersection. At least or stands for union here. And both stands for intersection. This stands for union. Okay, so we use again that addition rule. So n of E union H, that is equals to n of E plus n of H minus n of E intersection H. So you just put the values and simplify. So we'll get the number of persons who speaks both E intersection H, which is equals to 50. So that you can do just simple simplification. So here, this middle questions you can try. I'll go to 7th question. In a group of 65 people, 40 likes cricket, 10 like both. Both means intersection, remember. How many like tennis only? And how many like tennis? So let's see this 7th question. So I'll write here, let C be the people who like cricket and T be the people who like tennis here. So you are given total number of persons in a group. So total union, which is 65. Number of people who like cricket, which is C, which is 40. And both, that is intersection. So number of people who like both means intersection, which is 10. Now you are asked to find two things. So first question is this, number of people who like you are asked tennis only, that is T minus S. That's the first question. And the next question is number of people who like tennis. This is the second question. Two things you are asked. Tennis only means tennis but not cricket, that is T minus C. And here tennis only. So I think we'll get this first. So using this addition rule, C union T equals to n of C plus n of T minus n of C intersection T. So if you put all the values here, you know n of c, which is 40. This you want to get, you know this. So from this you will get n of t, which is nothing but 35. So number of persons who like tennis, you know union 65, you know this is 40, this you want to get, this is 10, so we'll get 35 here. Now first question, number of persons who like tennis only. Tennis only means tennis but not cricket. So in a Venn diagram, if you see this, for example, this is tennis and this is cricket, then you are finding this much. So what is that? Number of persons who like tennis, which is how much? You did here 35 minus common. Common how much? You are given 10. So which is 25. Now if you write the formula here, n of t minus n of c intersection t. Right? So this way you can get.